Heat death. Picture the very last star in the universe, flickering out with no others left to replace it. This is where the slow ending begins. Everything cools. Over unimaginable stretches of time, stars burn out, matter decays, and even black holes leak away their mass until they vanish, somewhere around 10 to the 100th power of years from now. What's left is a thin, cold soup of particles drifting apart in the dark, all at the same temperature. Nothing moves, nothing reacts, nothing changes. The universe doesn't explode or collapse. It simply runs out of anything left to happen. Big crunch. Now run the expansion backwards. For a long time, everyone assumed the universe would keep growing forever, but a 2025 study using new dark energy data suggested something else, that the expansion might one day stop and reverse. If that's right, galaxies would slowly fall back toward each other. The night sky would grow brighter and hotter as everything crowds together. In the final moments, stars, planets, and atoms would be crushed into a single searing point. The Big Bang played in reverse. It's still just one model, not settled science, but the new data pulled the idea back to life. Big bounce. Some scientists ask a simple question: what if the crunch isn't really the end? In this picture, the universe collapses to a tiny point and then rebounds, exploding outward into a brand new Big Bang. Reality doesn't die, it resets. Everything that ever existed gets erased and rewritten, and a fresh universe grows in its place, maybe with completely different laws. If it's true, our Big Bang might just be the latest in an endless chain of universes, each one born from the ashes of the one before it. Big Rip. This one doesn't crush the universe, it tears it apart. If dark energy keeps getting stronger over time, a version of it called phantom energy, the expansion of space itself turns violent. First galaxy clusters are pulled apart, then individual galaxies, then whole solar systems. In the final hours, the space between the Earth and the Sun stretches so hard that the planet simply drifts away. About half an hour before the end, the Earth is torn open. In the last fraction of a second, even atoms are ripped apart. One estimate puts this roughly 22 billion years away. But only if phantom energy actually exists. False vacuum. Here's an unsettling thought. What if the universe only looks stable but is really sitting in the wrong place? Physicists picture the Higgs field like a ball resting in a shallow dip. It seems settled, but there may be a deeper dip nearby, a lower, truer resting point. Measurements of the Higgs particle since 2012 hint that we might be sitting in one of these fake, temporary states called a false vacuum. It could hold steady for billions of years, or it could give way at any moment, with no warning at all. Vacuum decay. This is what happens if the false vacuum finally breaks. Somewhere at a random point in space, a tiny bubble of the true vacuum pops into being. Inside that bubble, the laws of physics are rewritten, and matter as we know it can't exist. The bubble then expands outward at the speed of light, swallowing everything in its path. And because nothing travels faster than light, you would never see it coming. No flash, no warning signal. One instant you're here, and the next the bubble has already passed. You simply stop being part of the universe. Strange matter. Deep inside dead stars, matter can be squeezed into a strange new form built from exotic quarks. A tiny piece of it is called a strangelet. The frightening idea is that if one ever touched ordinary matter, it might turn whatever it touched into more strange matter, spreading like a chain reaction until an entire planet became a dense, dead lump. People sometimes call this an Ice Nine scenario. Most physicists think it can't actually happen. Cosmic rays have hammered the Earth for billions of years without triggering it. But the possibility still lingers at the edges of physics. Proton decay. We like to think protons last forever, they might not. Some theories predict that the proton, one of the building blocks of every atom in your body, very slowly falls apart, with a lifetime of around 10 to the 34th power of years. That number is so huge it's almost meaningless, far longer than the entire current age of the universe. But if it's true, then given enough time, every atom everywhere eventually crumbles. Long after the last star has died, matter itself would quietly dissolve into stray particles and faint light. Bubble collision. If our universe is only one of many, we might not end on our own terms. In some models, space is constantly sprouting new universes, each one a bubble inflating inside a vast sea. Usually these bubbles never meet, but every so often two of them could drift close enough to collide. If another universe's bubble expanded into ours, the crash could rewrite our physics along the boundary, or erase everything at the point of contact. And we'd have no way to spot it coming. just a wall of foreign reality rushing toward us. Boltzmann Brain. Here's a genuinely dizzying one. In a universe left to random chance for long enough, particles can, by pure luck, arrange themselves into almost anything. Some physicists realized it might actually be more likely for a single conscious brain to flicker into existence out of the empty void, complete with fake memories, than for a whole ordered universe like ours to appear. Which raises a deeply strange question. How do you know that you aren't one? It isn't really a prediction. It's a warning flag that tells physicists a theory has broken somewhere. Quantum immortality. Imagine facing something that should kill you instantly. In the many worlds idea of quantum mechanics, every possible outcome actually happens, each in its own separate branch of reality. So in at least one branch, by sheer chance, you survive. The strange conclusion some people draw is that you can only ever experience the branches where you're still alive, meaning from your own point of view, you might never truly die. It's a haunting thought experiment, not a real plan, and almost every physicist rejects that it works in the real world. Still, it sticks in the mind. Simulation shutdown. And finally, the strangest ending of all. If our entire universe is a simulation running on some vast computer, then reality wouldn't end with a freeze or a bang. It would end the moment someone or something switched it off. No warning, no physics to blame, just the program closing. There's no evidence for this and no way to test it. But it's a reminder that every single theory about the end of everything quietly assumes the universe is real to begin with. And that too is something we can't actually prove. Thanks for watching, and if your brain enjoyed this, subscribe for more.